Okay, for this video we're going to practice a few more writing equations. I'm going to start with 3x plus 2y is equal to 8. And what I want to do here is write y as a function of x. Okay, so as a function, you can think of this as an equal sign. So in other words, I want to solve for y so that I have y equals something else happening on this side of x. So I'm going to go ahead and box in my y. Anything that does not have a y on this side, I need to get it off this side and move it to the other. So this is a positive 3x, so I'm going to minus 3x. That eliminates there. But I also have to have a minus 3x on the other side. Now since this doesn't have an x on it, I can't do 8 minus 3. All I can do is express it as 8 minus 3x. I still have a 2y left over on this side. Now I need to get rid of my times 2. What we're going to do is, instead of dividing by 2, we're going to multiply by the reciprocal, which is 1/2. So on the other side, we're going to multiply by the reciprocal 1/2. 2 times a half is 1. 1 times y is y. And now we're going to distribute our 1/2. 8 times a half gives you 4. And negative 3 times a half gives you 3/2, and I still have an x attached. Don't divide this out and call it 1.5. We're going to just leave it as negative 3 over 2x. Now technically this is the value. However, we want to put this in a more standard form in which we have all the variables up front and the constant values in the back. So all I'm going to do, put a little box here and then a box there. I'm going to take this entire box and put it up front. So that's a negative 3 over 2x, so I'm going to write it as minus or negative 3 over 2x, followed by a positive 4, and I'm going to connect that with a plus sign. And even though this is equal to this is the way that we should display it, where y is a function of x. So we solve for y by itself, and its value depends on whatever x calculates out on the right hand side. Let's go ahead and try an actual formula where we have to rewrite the formula. And we'll start with one that actually has a fraction in it. Area formula of a triangle, where area is equal to 1/2 base times height. And let's suppose we want to solve for h, or the height. We are going to put a box around this, and we look at outside. I have a times a half and a b, and technically we could get rid of both at the same time. However, I always recommend to my students, if there's a fraction involved, get rid of the fractional portion first. So if I have a times 1/2, to undo that, I'm going to times the whole thing by the reciprocal, which is 2. So I'm going to times this side by 2. So 2 times a becomes 2a. A half times 2 becomes 1, leaving b times h left over. I still want to solve for h. Now to detach the b from the h, this is a times, so to undo that we're going to divide both sides by a b. And now we have h equal to 2 times the area divided by the base. Alright, I'm going to try one more of those y as a function of x problems. Let's say we have 5x plus 4y, and let's suppose that that equals 20. And we want to write y as a function of x. So in other words, we're just solving the problem for y. So put a box around the y. Anything that doesn't have a y in its term gets moved to the other side. So I have a positive 5x here. So I'm going to move it to the other side as a minus 5x. So I'm going to rewrite my problem. 4y is going to equal 20 minus the 5x coming over from the other side. Then to get rid of the times 4, I'm going to multiply by the reciprocal of 1/4. 1/4. 1/4 of 4 is 1. 1 times y is just y. Now for this one I'm going to go ahead and show this in the long way. So I'm going to do 20, which is 20 over 1, times 1/4. So I am going to distribute. So I get 20 over 4 minus, this is 5 over 1. 5 times 1 is 5. 1 times 4 is 4. So I have 5/4 x. And then this one right here can be simplified. So I'm going to call that y equals 5 minus 5/4 x. We're not going to call this 1.25. We're going to leave it as an improper fraction, 5 over 4. And technically this is correct, but I'm going to go ahead and change it a little bit. I'm going to take my variable and move it up front and move my constant to the rear. So that would be a negative 5/4 x. And this was a positive 5, so I'm going to connect it to that with a plus 5. This had a positive 5 value on this right hand side, so no matter where I move it in the problem, it still has to have a positive 5 value. Same thing as this negative 5/4. It started out as a negative 5/4, so no matter where I move it on this right hand side, it still has to have a value of negative 5/4.